Hi, let's take a look at how we can use a calculator to help us solve quadratic equations and inequalities. This skill was actually covered in an earlier video, but I think it's worth noting so that you can make sure that you're understanding everything. So if I wanted to find the solutions of the equation 1/6x squared plus 1/6x equals 5. Now if I was doing that by hand, I could multiply through by 6 to clear fractions, set it to 0, use a quadratic formula, and be on my way. If I wanted to do this on the calculator, there are two ways. Do you remember we talked about either the x-intercept method or we've talked about the intersection of graphs. Now to do the x-intercept method, I would have to set the equation equal to 0, right, and then find the x-intercepts of the graph. The intersection of graphs, I could let one side be y1, the other side be y2. So let's look at how both of these methods would transpire. So let's say we're going to do the intersection of graphs. So I'd have to do 1/6 x squared plus 1/6 x, and then that is equal to 5. And so if we graph that, and I'm in the standard viewing window, maybe I'm not in the standard viewing window, let me reset that. Okay, there we go. We see that we have two solutions. So if I wanted to find these solutions, I would have to do second and trace and select intersect, which is 5. First curve, we see it displayed, so we press enter. Second curve is displayed, we press enter. Now this is the important step here. When you have 2 points of intersection, you do have to move close to the point of intersection and press enter. That will allow the calculator to know which one it's computing first. So there's an intersection of 5, 5. So remember that x value is one of our solution points. So we know that x is equal to 5 is a solution. To do the other solution, we're going to have to repeat the process. So do second, trace, 5. And now first curve is displayed, yes. Second curve is displayed. And our guess, we need to go to the other point of intersection. And press enter. Okay, so we see -6, 5. So that tells us that the other solution is -6. Okay, so that was where we did one equation into y1, the other equation into y2, and then we did second, trace, five. Okay. Now if I wanted to do the x-intercept method, do you remember what I'd have to do? I'd have to say 1/6x squared plus 1/6x minus 5, and that's equal to 0. But I don't need to put that in there because equal to 0 is on the x-axis. So if we graph, now to solve it, I would be looking for the x-intercepts. So if I press second, trace, x-intercepts would be the 0 values, so 2. So if I'm trying to find this x-intercept here, the left bound is to the left, which is really below it. So we press enter. The right bound is above it, and we press enter, and guess is in between there. So we see 1, 0 is 5, which means our solution is 5. We would repeat that process, second trace, 0. Now left bound, we need to be all the way over here, so let's say like -10 or negative 9. Okay. And a right bound, let's see, 1, 2, 3, 4, let's say negative 4. And a guess is somewhere in between those two marks, and we see negative 6. Okay, so we have found it in either way. So the x-intercept method, we had to say 1/6 x squared plus 1/6 x minus 5, and that's what we put in y1. And then we had to do second trace 2. And we still find 5 and negative 6 are our solutions. Okay? Coming back to you. So now let's look at how would we solve the quadratic inequalities. Kind of a similar way. I mean, we have a lot of ways to do this. We can first enter the function, right? We can enter x squared plus 4x plus 3 and graph. Now, remember what we're looking for. This parabola crosses the x-axis in 2 points, right? These points are the solutions, but we would be looking for where is it greater than or equal to 0, and greater than or equal to 0 is where it lies above the x-axis. So that would mean we have to know this solution and go to the right, know this solution and go to the left. So you're not going to be able to avoid being able to solve the equations by hand. Well, I guess you could technically. You could find the zeros or the x-intercept method on the calculator or intersection of graphs and then go from there. So knowing the graph tells you exactly which pieces of that number line, right, are included, because if our number line, if you remember how we do it by hand, we place solution A and solution B on the number line and we had to test points. When knowing the shape of the graph eliminates that testing for us, because to be greater than or equal to 0 means that the graph is above the x-axis. And so therefore we can know that this region and this region would test true. Now do you remember you can also actually input the whole entire inequality? Oops. To input the entire inequality here, you could do second math to get the test menu and do greater than or equal to, which is option 4, greater than or equal to 0, and then graph. So there it shows you which regions you would need to include in your solution set. Okay? Now I have one last problem we'll talk about. 2x squared minus x plus 3 is less than 0. So just to kind of show you the graph and how things would look on this. So if I enter 2x squared minus x plus 3, okay, let's do it this way with just looking at the graph. Okay, notice what happens here. If I draw my graph, I see that it has a shape that looks something like this. Okay, doesn't really matter what it is, but do you notice how it nowhere crosses the x-axis, which means there are no solutions to where it's equal to 0. It's all contained above. So whenever I'm trying to solve where it's less than 0 would mean it has to be down below the x-axis, which that doesn't happen anywhere. So that would tell me, just from looking at the graph, that the solution to the first part would have to be the empty set. Now what about the solution to the second part where it's greater than or equal to 0? Well, it's all greater than 0, right? It's all above the x-axis. Doesn't happen to be equal to 0, but that's okay. because it satisfies one part of it, so that solution is going to be negative infinity to infinity. Now, if I wanted to do this all on the calculator, I could, right? Oops. To do that on the calculator, I could say where 2x squared minus x plus 3 is less than 0. So if I do second in math, less than 0 is option 5. And enter. And then graph. I see that nothing gets graphed, so that tells me that's the empty set. If I change that to be greater than or equal to 0, and graph, that's everywhere. So that's just a way to use the calculator to solve equations and inequalities. So if you have any questions, don't hesitate to contact me. Thanks.